going to take a look at EPO right now, also known as erythropoietin. These are the things we're going to take a look at today. So when you're doing your study sheet, these are the parts you need to make sure you include. So EPO, also known as erythropoietin, also has two other names, hematopoietin and hemopoietin. Erythro means red, poiesis means to make. So the word literally means to make red, and just put blood cells on the end of that. So we're making red blood cells. This is the hormone that triggers the production of red blood cells. Now, what are the stimuli? The main stimulus here is low oxygen levels. Low oxygen is also referred to as hypoxia. And the cells that detect that are actually coming from the kidney, believe it or not. So as the low oxygen levels of blood pass through the kidney is the one that says, oh, okay, I'm detecting low oxygen levels of in the blood. I'm going to go ahead and make erythropoietin. So the kidney cells pick up the low oxygen levels and respond accordingly. Now, here are some other stimuli, but they all go back to low oxygen levels. So anemia, sure, if you've got anemia, you're going to have fewer red blood cells, which means you're going to have less oxygen in the blood. Low hemoglobin, and that's the protein that binds oxygen. So if you don't have hemoglobin, you can't bind oxygen. So again, that's going to result in low oxygen levels. Poor blood flow. Again, if you're not getting blood to a certain area, especially the kidneys, right? The kidneys are going to pick up on that as low oxygen levels. And pulmonary disease, if you just can't breathe, you're not going to get oxygen. So while you may have fine hemoglobin, you can't get the oxygen to pass through the lungs in the first place. So the ultimate stimulus is low oxygen levels from any one of these causes. Again, it's secreted from the kidney cells. We're not going to talk about specifically which kidney cells. We're just going to say kidney cells in general. Now, the target cell, remember where red blood cells get made. Red blood cells get made in the red bone marrow. And the cell that actually makes that leads to the production of red blood cells, is called a hemocytoblast. This is actually the cell that results in the production of red blood cells. So you've got this hemocytoblast sitting here in the bone marrow, and it could make literally anything. It could turn into a white blood cell, a red blood cell, or a platelet. So how does it know, you know what, today I think I need to make some red blood cells, an erythrocyte? How does it know? When erythropoietin shows up, that lets this hemocytoblast know it's supposed to make erythrocytes rather than something else. So again, the target response is the production of red blood cells. So again, while that hemocytoblast is in the bone marrow, that's the EPO dependent phase, right? So your hemocytoblast is going to result in the production of red blood cells because it is exposed to EPO. And this just kind of shows all of the different things that that a hemocytoblast can lead to the production of. So here's your hemocytoblast up here. And again, yes, it can form a red blood cell, which is the pathway that we're looking at, because that hemocytoblast is exposed to EPO. Now, it could form your thrombocytes, it could form your white blood cells, right? So those could also, and there's your other white blood cells down here, but it could also form that red blood cell. This is a peptide hormone. So it's made of more than one amino acid, but fewer than like 1,000 amino acids. So it's somewhere in between. It's that peptide hormone. And this just kind of shows you the summary of what's going on. So again, that stimulus, the initial problem is low oxygen levels, which are detected by the kidney. The kidney then secretes erythropoietin, and that travels through the bloodstream to the bone marrow. When it reaches the bone marrow, it is going to cause erythropoiesis, which is red blood cell production. And because now you have more red blood cells, you have an increased oxygen carrying capacity, which is going to put the blood back to normal as far as oxygen levels go. This is an example of negative feedback. And that's it.